Okay, let's look at some of the hard problems here on page 622. I'm going to start with number 28. Find the surface area to the nearest whole number here. 28 is a very strange looking figure here. It looks like a pyramid on top of another pyramid, but you're going to figure out the surface area. So whatever's exposed to the surface. There's a bunch of triangles. There's 4 on the top, and there's 4 triangles on the bottom. So I drew a net, although I'm not sure a net is going to be too useful for this problem. But there are 8 triangles, 4 on the top, 4 on the bottom. Do not include this square in the middle here. That is not on the surface. So you don't want to include that at all. All right, with these triangles, and I took this one triangle here and I just highlighted it. If I can figure out the area of one of these guys, I can just multiply it by 8. I redrew it over here. I have a base of 4. What I need is that height, which in the 3-dimensional picture, it is the slant height. So I will draw it from here to here. I need that guy there, and then I can figure out the area of one triangle. Well, if you look carefully inside the figure, you will see a height of the pyramid, which is 3. This is half of the edge. If the entire edge is 4, this must be 2. And so we have a 3 by 2 by c squared. Okay, so it's a squared plus b squared is equal to c squared. And this ends up being 3.6. The square root of 13 is 3.6. So again, this is 3.6 here, this slant height. And so the area of one triangle is 1/2 base times height. The base is 4. And the slant height is, as we just figured out, 3.6. The area of one triangle is about 7.2111. I'll go with 7.2. And we can, put 7.2 in there, 7.2 in there, or basically since there are 8 triangles exposed to the outside surface of that figure, I'm just going to multiply by 8. And my answer is 57.6, but they want it rounded to the nearest whole number. So that would be 58 meters squared. Basically 8 triangles. Okay. Okay, now I'm going to do number 29 here. I copied it down here, and essentially it looks like a cylinder on top of a cone. But we want to figure out the surface area. Really, it's broken into 3 parts. It's a regular circle on top. It is obviously a rectangle when you open that up, and it is the triangle on the bottom. The one thing you do not want to include is with a cylinder, there's usually 2 circles. Well, you don't want to include this circle here in yellow because it's not part of the surface. So just the one circle on top, which of course the area of a circle is pi r squared, the radius is 5. The middle part is a rectangle. 6 is the height. This, of course, is circumference, which is 2 pi r. Radius, again, is 5. So we're to figure out the area of the middle is base times height. So the base is 2 pi 5. That's circumference times the height of 6. And now this guy here is the area of a triangle. And, of course, that would be 1/2 base times height. Now, before you go off and just use the number 12, this 12 is not on the surface, but we are going to see a right triangle here, and we're going to want to figure out what this slant height is here, and I guess I'll highlight it here in green. Okay, and of course that means a squared plus b squared is equal to c squared, and to save us time here, I know that answer is 13. So that slant height in green appears right here. It goes from the highest point to the base there, 90 degrees. That is, again, 13. So the area of this triangle is 1/2. Again, don't forget the 1/2 because it's a triangle. This is circumference, the base, so that is 2 pi 5, and then multiply it by the slant height that we just discovered, 13. Alrighty. This, with the calculator, turns out to be 78.5. That's the area of the circle. The area of the rectangle is 188.4. Obviously, you're going to need a calculator here. Throw in the area of the triangle. This is 204.1. The entire surface area And again, let me stress, you do not include that second circle in the middle because it's not part of the surface. The entire surface area is 471. This is feet squared. Okay, break it down into what is exposed on the surface.